Europe has to be climate neutral by 2050, and it needs to reduce at least 55% of CO2 emissions by 2030. The reduction of CO2 tons emitted by cities can be averaged over several factors such as vehicles, heating, or lighting. The creation of low-emission zones is in the spotlight of cities, but urban planners need to have a clear vision of the city's status to deploy the correct type of low-emission zone in a high-impact area of the city. For that reason, in the fight against climate change, smart tools for evidence-based decision-making are crucial. Atmosphere is a software as a service that uses all the city's data to understand the best areas to deploy different types of low-emission zones and predict the impact of the city's air quality. In addition, Atmosphere shows the current status of pollution in the city to monitor and analyze the impact of decisions related to the climate objectives. The main objective of this tool is to reduce the CO2 produced by different means of mobility through evidence-based decision-making. Thanks to artificial intelligence models developed by Hopu, Atmosphere mixes contextual data, that is, corrosive gas emissions such as CO2, O3, etc., together with weather conditions and human dynamics, meaning demand and use of transport and buildings, to provide different scenarios about the impact of low-emission zone and parking spaces. Therefore, it shows the potential for the reduction of CO2. The Atmosphere project includes the deployment of smart spots, high-quality monitoring devices for pollution, noise and crowds to provide real-time data to improve and increase the information fed to AI and at the same time to the platform. Atmosphere main values. Atmosphere is the first tool on the market that can predict the best location for the implementation of LESS, allowing city managers to simulate the implementation of 10 different types of LESS and to see the impact. On the one hand, it provides a heat map with different colored cells according to the effects of LESS in a specific area, whether it's recommended, required, or how much of an impact it would have. Besides pointing out the best location for LESS, the tool allows the user to manually select the desired area and activate up to 3 LESS combined on the map, providing a high range of scenarios for cities to analyze. Thanks to the prediction service, Atmosphere shows the reduction results once the LESS has been applied to a specific area and the effect of the surrounding environment. All of this is possible thanks to AI. Moreover, Atmosphere makes it possible to monitor the evolution of the applied changes thanks to its deployed sensors network and a final dashboard with different indicators such as CO2 values originated by different sources such as mobility, industry, etc. Compared to traditional geographical information systems, which provide static information, Atmosphere offers real-time dynamic information. Following the 5-word approach, Atmosphere integrates different datasets to feed the AI and contextualize the effectiveness of every action. All the software created is based on open standards, leading to a total reduction of license costs that would need to be assumed by the cities in the future. How does it work? It's very simple. Just type in atmosphere.hopu.eu in your browser and you'll land on the homepage where all 5 cities are located. To facilitate the testing process, access is now open to everyone. Click in your city panel. In the main dashboard called Monitoring Overview, you can see the Smart Spots devices deployed in the territory. These virtual devices will currently be real deployments in the 3rd phase of AI for cities. The menu on the right shows all different functionalities promised in Atmosphere. Low emission zones recommendation is the main tool of the project. Air quality index calculation, gases levels, particles matter levels, noise, and crowds information. If you move your mouse over the eye for info of the different sections, a pop-up message will provide a short description of the section. In the low emission zones location recommendation section, you can find out the best locations for implementing 10 different low emission zones. Indicators about CO2 traffic values from different mobility sources are also available in this section. The information is divided into different sections. Small description of the section, a heat map that shows the recommended areas for implementing LESS based on all the data integrated into Atmosphere with the caption on the left, a panel to select the different types of existing low emission zones and default scenarios, and the CO2 traffic values of the city. To test the different types of low emission zones, Select a desired area on the heat map and choose the type of restriction in the menu on the left. You can customize different areas with up to 3 of the 10 types of low emission zones simultaneously, or use one of the default scenarios that the platform creates for this case, based on the artificial intelligence and integrated data. Then click on Generate Dashboard. You'll automatically land on a new dashboard with a heat map that shows 3 types of forecast, showing the average results obtained regarding CO2 levels, traffic values, and the reduction in the use of private vehicles after implementing the selected list for 40 days. Atmosphere includes indicators based on the smart spots data. Here, the user can see the levels of nocive and greenhouse gases, particles matter, AQI index, and the levels of noise and crowds in different locations. This project is led by Hopu, an SME from Spain, and Engineering, a larger company from Italy. Atmosphere. Be part of the change.